Previously, we discussed that when we add rational expressions with common denominators, that it's a fairly easy process. Now, we're going to talk about what we do if we have different denominators. Now, before we get into this, let's review how you add fractions that have different denominators. So, for example, say I have 2/3 plus 4/7. Now, there's kind of different ways you can set this up, but probably most of you are familiar with doing it this way. So what we do is we line it up top to bottom. So I take 2/3 and then plus the 4/7, and I write it vertically like this. And what we need to do is we need to find a common denominator of the 3 and the 7. And there's different ways to get a common denominator. One way you could get a common denominator is simply to multiply the two denominators. I could take 3 times 7, and 21 would be a common denominator. Usually the best way to get a common denominator is to think of what the least common multiple is of the two numbers. So let's look at 3 and 7. If I'm thinking of the multiples of 3, 3, 6, 9, 12, 15, and so on, and the multiples of 7, 7, 14, 21, I'm going to find that the least common multiple is 21, just as I said before. Really, the main thing is that we want to make sure that that I can multiply 3 times something to get my common denominator. And I want to make sure I can multiply 7 by something to get that common denominator. Now, 21 works, right? Because 7 times what is 21? Well, 3. So I got to multiply the top times 3, and I get 12. And this is something you've had quite often in the past few years. Now, what could I multiply 3 by to get 21? Well, 7. So I multiply the 2 times 7, and I get 14. Now I can add these fractions because they have a common denominator of 21. 14 and 12 is 26, and I could leave my answer as 26 over 21. You could write it as a mixed number. You don't necessarily need to. So that's how you that's how you add fractions with different denominators, is that you got to find a common denominator or a least common multiple. All right, let's take a look at example 1. Now, I've got two fractions here, or really I've got two rational expressions, but they have different denominators. So I'm going to write this problem vertically, like that, and I need to find a common denominator, or in other words, the least common multiple of 4 and b. So if I asked you, if I had 4 and I had b here, and I asked you, what's the least common multiple of 4 and b? Well, remember, least common multiple, they don't have to be in both of them. So I've got a 4 and I've got a b. Or remember what I said on the previous screen. To get a common denominator, you could just multiply the two together. 4 times b is 4b. Now, this makes sense because 4 times what is 4b? Well, 4 times b is 4b, right? So I got to multiply the top times b, and I get 3b. In the bottom, b times what is 4b? Well, b times 4 is. So I have to multiply the top by 4, and I get 8. Now I add these together, and I put it over my common denominator of 4b. So I have 3b plus 8 over 4b. Now, can I add 3b plus 8? Answer is no. They are not like terms. And that's all I can do with it. For example, I cannot cancel out the b's here, because up here there's addition associated up there. The only way I could cancel out the b's is if I had something like this. If I had 3b over 4b, where just multiplication's involved. Then I could cancel them out and get 3/4. Here, this is hooked onto the plus 8. I'm done. That's all I can do with it. All right, let's do another one. Let's take a look at example 2. So I'm going to write this vertically because I do not have common denominators. And I'm going to find a common denominator for b, c, and 2. And remember, there's a couple different ways of looking at this. If I have b, the c, and 2, what's the least common multiple of those? Well, it'd be 2bc. Or think of it this way. To get a common denominator, you can just multiply those together. Multiply these together, and you get 2bc. So 2bc is my common denominator. All right, let's finish this out. Let's see, b times what is 2bc? Well, I have to multiply it by 2c, right? Because b times 2c is 2bc. So I got to multiply the top times 2c, and I get 8c. All right, multiply c times what to get 2bc? Well, 2b. So multiply the top times 2b. 1 times 2b is simply 2b. 2 times what is 2bc? 2 times bc. So I multiply the top times bc. And 1 times bc is bc. All right, now add them together because that's what the problem's asking you to do, right? Plus, plus. So 8c plus 2b plus bc. Now, are any of those terms in the top like terms? Answer is no. You're done. That's my answer. I've added the rational expressions. All right, I'm going to go through this one a little faster. All right, so I'm going to find a common denominator. I have 5 over x. I have x over b. And I have a over c. Okay, what is my common denominator for x, b, and c? Well, the least common multiple, or when I multiply x, b, and c together, I just get simply xbc. So xbc is my common denominator. All right, now let's get our numerators. Let's see, x times what? And that's kind of why it's not good to use the variable x, because you can see that it gets confusing with my multiplication sign. But x times what is xbc? We'll multiply it by bc. So you multiply the top times bc. That's 5bc. B times xc. Multiply the top times xc. And I'm getting my x's and multiplication symbols mixed up. So times xc. So x times xc then, and really I should use a raised dot, but that's okay. What is x times xc? What's x times x? Add the exponent, so it's x squared c. Let's see, c times xb gives me xbc, so multiply the top times xb, and I get axb. All right, so what do I have now? I have 5bc plus x squared c plus axb all over my common denominator of xbc. Now, is there any like terms in the top? So in other words, here, here, or here, these three terms, are any of those like terms? Answer is no, so you're done. Okay, last example, and I just want to, this one's a little different. So again, I don't have a common denominator. Think of 6 as 6 over 1. So I have an m over c cubed. I have a 4 over c squared. And I have 6 over 1. And I want to find my least common multiple. Well, what's the least common multiple of c cubed and c squared? How do you find the least common multiple? If they are common in both, what do? What's the rule? You take the larger exponent. So I've got a c cubed in all of them, right? And then here, it's a denominator of 1, so really I don't need to write 1 c cubed, in each of those, because 1 c cubed, or 1 times c cubed, is just simply c cubed. Right, now let's finish this out. C cubed times what is c cubed? Times 1. So I multiply the top times 1. C squared times what is c cubed? What would I have to multiply c squared by to get c cubed? Well, I'd have to multiply it by c, or c to the first, right? Because c squared times c to the first is c cubed. So 4 times c is 4c. And finally down the bottom, 1 times c cubed is c cubed, so I got to take the top times c cubed. That gives me 6c cubed. Final answer over c cubed is, now here I'm going to add the first two, so m plus 4c, and then subtract the last one, minus 6c cubed. Now, is there anything in the top that are like terms? Answer's no. So this is your final answer.